Hi students, welcome to the video lecture 5 of module 4 topic queuing theory. In lecture 4 we discussed about operating characteristics of queuing system, that is what is queue length, waiting time in the queue, waiting time in the system and length in the system and all. And we also discussed about list of formulas and we solved one problem. In today's class again we'll see what are the formulas and we'll solve some more problems. So topics to be covered in this lecture is numerical. So here the formulas I have just kept as it is so that you just go through it. So what are this? Traffic intensity is nothing but busy, that is server is busy. Probability of system is idle is nothing but 1 minus lambda by mu. Expected waiting time in the system Ws. Expected waiting time in queue WQ. Expected number of customers in the system LS. Expected number of customers in the queue, that is LQ. Non-empty queue it LNEQ. And more than k customers are equal to more than k customers. What is the probability at least one customer is standing in queue? What is the probability at least two customers in the system? So I have just gone through the formulas again. So let us see the problem. It is again a V2 previous year question paper problem. Problem definition is: a box office ticket window manned by a single server. Customers arrive to purchase tickets according to Poisson's distribution with a mean rate of 30 per hour. So in 1 hour 30 customers arrive. The time required to serve a customer as an exponential distribution with a mean of 90 seconds. So each customer is served for 90 seconds. Determine mean queue length, that is LQ, mean waiting time in the queue, that is WQ, probability that more than 3 or more customers in the system, that is P greater than or equal to N is there, K is there, here K is equal to 3 here, percentage of time the server is busy, that is nothing but P here. Okay. So now let us calculate the given data. So they are told that every 3600 seconds, that is 1 hour, 30 customers arrive. Therefore, for 1 second is equal to 30 divided by 3600 customers arrive. That is mean arrival rate is equal to lambda is equal to 1 divided by 120 customer per second. So if you simplify it, you will get 1 divided by 120. Similarly, every 90 second one customer is served. Every 90 second one customer is served. Therefore, for 1 second 1 divided by 90 customer is served. 1 divided by 90 customer is served. That is mean service rate mu is equal to 1 divided by 90 customer per second is served. Now as I already told, mean queue length is asked, that is nothing but LQ, that is lambda square into mu minus lambda. So you need to substitute the values like this. After solving you will get LQ is equal to 2.25 customers. Since we can't have 2.25 customers, it is nearly equal to 2 customers. Mean waiting time in the queue, that is nothing but WQ, which is lambda divided by mu into mu minus lambda. So substitute the values of lambda and mu. I have substituted here. After calculating we will get 270 seconds as the time. So when it comes to time you need to write in terms of minutes or second. When it comes to queue length you need to write in terms of customers or whatever the give. Next is probability that more than 3 or more customers in the system, which is nothing but lambda by mu whole cube, lambda by mu whole cube, which is equal to 1 divided by 20 into 90 by 1. So which is coming 42 percentage. Percentage of time the server is busy, that is nothing but lambda by mu, it is coming 0.75, that is nothing but 75%. Okay. Now let us go to the third problem. It is also previous year V2 question paper problem only. Patrons arrive at reception counter at an average interval time of 2 minutes, that is one patron arrives for 2 minutes. The reception on duty takes an average of 1 minute per person. Arrivals are as per exponential and services are as per Poisson distribution. So many parameters are asked here. What is the probability that a person will straight away meet the receptionist? For what portion of the time the receptionist is busy? What is the average queue length? What is the average number of patrons in the system? What is the average waiting time of a patron? What is the average time a patron spends in the system? So what is the probability that a person will straight away meet the receptionist mean? So idle is what asked, probability that receptionist is idle is asked. For what portion of time the receptionist is busy is nothing but traffic intensity. Average queue length is nothing but LQ. Average number of patrons in the system is nothing but LS. Average waiting time of a patron is WQ, and average time a patron spends in the system is nothing but WS. So all are very simple here. So now let us see the given data. Every 2 minutes one patron arrives at a reception counter. For 1 minute 1 divided by 2 patron arrives. 1 divided by 2 patron arrives. That is mean arrival rate is equal to 0.5 patrons per minute. Similarly, the receptionist on duty takes servers on average of 1 minute per person per patron. Therefore, for 1 minute 1 divided by 1 patron is served, that is mean service rate mu is equal to 1 year. We are getting 1 year. Now let us solve the problem. So the probability that a person will straight away meet the receptionist is equal to probability that there is no patron in the system, and it itself is equal to probability that receptionist is idle, which is given by 1 minus lambda by mu. After solving you will get 50%, that is PO. Next is the pattern of the time the receptionist is busy is nothing but service utilization factor, that is P, which is given by lambda by mu, which is equal to 0.5 divided by 1, that is equal to 50%. So since we are getting this as 50%, this also you should get 50%. Next is average queue length. So we are kept the formula here. So after solving you will get LQ is equal to 0.5 patrons. Next is average number of patrons in the system, that is nothing but LS is equal to lambda divided by mu minus lambda. So we will get LS is equal to 1 patron. Next is average waiting time of a patron, lambda divided by mu into mu minus lambda, which is equal to 1 minute. Average time a patron spends in the system is in nothing but WS, which is equal to 2 minutes. Okay. So by this I conclude this lecture. So in next topic I will solve some more problems and I will conclude this particular topic, queuing theory. Thank you dear.